friends! Welcome to episode number 499 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Can you believe that we are just 1 week away from my 500th episode? And in honor of this momentous occasion, we have launched a special playlist on YouTube that spotlights one of my all-time favorite topics, robots. I don't know about you, but I love robots. Robots of all shapes and sizes. And you can binge all 9 episodes of this series by clicking the link below the player on this week's fish frying page on eejournal.com, by heading on over to our YouTube channel, youtube.com/eejournal, or simply by checking out the homepage of eejournal.com. Are you ready to grok and roll? I certainly hope so, because this week I am super happy to welcome CEO and founder of Groq, Jonathan Ross, to Fish Fry. Jonathan and I are talking all about Groq's innovative, deterministic, single-core streaming architecture, why developer velocity is cornerstone to the Groq philosophy, how Groq was able to accelerate COVID-19 drug discovery with their collaboration with Argonne National Labs, and why Jonathan believes that Star Trek: The Next Generation is a leadership goldmine. So, without further ado, please welcome Jonathan to Fish Fry. Hi, Jonathan. Thank you so much for joining me.
Hi, thanks for having me.
Absolutely. Okay, so we're talking about Groq today, but Jonathan, let's start out with the question here. What is the soul of your product?
That's an excellent question. All right, so the soul of our product is developer velocity. And developer velocity means being able to very quickly produce an outcome. The speed of iteration is the speed of innovation. And so the more quickly that a developer can take an idea and get it into production or get it working, the more quickly they can iterate on it and the more innovative they can be.
Okay, so now that you guys have some early customers, what are you seeing as having the largest impact on your customers relating to your solution?
So it might help to start with a specific customer as opposed to just being generic. So during the pandemic, we began working with Argonne National Labs, who's been a great partner, and they were trying to find drug candidates to use to treat the disease. And they were using GPUs. Unfortunately, those GPUs were kind of slow and they weren't able to produce candidates very quickly, and they weren't able to iterate quickly either. They were able to port their machine learning models used to do this drug discovery to our hardware, and they actually got a 300x speed up for the GPUs that were around at the time. There's been a new generation of GPUs, but it's still 200 times faster than the A100, the newest NVIDIA GPU currently out. And what they were able to do is, even though they had brought up this 2000 GPU supercomputer, it just took 16 of our chips to run their workload, and it was 50% faster than using the supercomputer. And so, since there's a limited amount of time that you can get on these supercomputers, they were actually able to generate drug candidates that they actually sent for testing using our chip. So our chip has actually been used to help find some of these drug candidates for COVID-19.
That's very cool. Now, what is the profile of a typical customer that's likely to benefit from your solution?
Yeah, so we focus on developer velocity. That's not just a tagline, that's a real thing. And if you want to take some idea or you've got a problem, you want to improve it or get it working in under 3 months, we're probably the best company to work with. If you don't mind waiting for 6 months, 12 months, 18 months, you should probably work with someone like NVIDIA. So NVIDIA has amazing white glove service. They'll get your code working. No one ever got fired for buying from NVIDIA, right? You're not going to have to deal with internal constituents who are like, why are you doing this weird thing with this startup called Groq, right? But it does take them 6 to 12 months to get something working on most customers' hardware. And so it'll be a nice experience, but it'll be slow. If you need something quick, though, As an example of another customer, a different lab, we did a workload for them, and actually it was a high priority workload. So NVIDIA was able to do it in 6 months. But in just 10 days, we were able to get it working on our chip, and it was actually running 7 times faster. So if you care about how quickly you get something into production, if that's one of the most important things to you, and especially if you want to do it in the next 3 months or less, then Groq is probably your best solution.
Okay, so I did notice your focus on developers. So tell me more about this developer velocity you mentioned.
Yeah, so where developer velocity came from, I'm actually a software engineer. I'm not a hardware engineer. My first chip, I did the TPU at Google. That's their machine learning chip. I actually started as a 20% project. But as a software engineer, I remember the build system at Google was amazing. The first project I worked on there, we produced 80 gigabytes of binaries, and it would take a minute. If you wanted to compile a 100 line of code C++ file or a 10 line of code C++ file, it would take a minute. It always took a minute. And a minute is good when it's 80 gigabytes. It's not so good when you're trying small experiments. So I actually built my own copy of Google C++ compiler. I kept it on my desktop because then I could compile things in under a second. I could change a couple lines of code, I could compile, and I could know whether or not it works. So with the Groq chip, we had the same philosophy. It was that speed of iteration is the speed of innovation. How quickly can you get something working? How quickly can you try things? And so a lot of what we've done makes it much easier for the developer. For example, normally when you write software, you have to run it thousands of times and measure how long it runs for in order to know how fast your software is. It's called benchmarking. But with the Groq chip, at compile time, you just compile the program, and we'll tell you this program is going to run for 42,517 nanoseconds plus or minus zero. There's no variation. So you don't have to benchmark your code. And also when you're debugging, we have this visual debugger that shows you the data moving through the chip on a cycle by cycle basis. So you can see where performance issues might be coming from. This is just a thing you can't do with GPUs and can't do with TPUs, and even with CPUs is pretty difficult. So when we talk to customers, they often talk about how using a GPU is a sign of failure. What it means is they weren't able to solve the problem on a CPU where it's easy to develop. And that sounds weird because everyone thinks of GPUs as the chips that people use for machine learning, but it is viewed as a failure because of that difficulty. And we want to make it super easy for people to get their code running.
That makes sense. Now, it seems like what you guys do is pretty hard. But Jonathan, do you just hate GPUs?
I really like GPUs. Fun story. So when I was in college, so I think back in 2007, I was actually taking a class with Jan LeCun. Jan LeCun's pretty famous in machine learning. He won a Turing Award. He was one of the 3 who won Turing Awards for basically coming up with the algorithms that make machine learning work. And I got access to CUDA closed beta. CUDA is the software that people use to program NVIDIA GPUs. And I ported Jan's library over to the GPUs and got a huge speed up, and it was awesome. And I've been playing around with GPUs ever since. I love GPUs, but I also love CPUs. And it wouldn't make sense to use a GPU for some things. You might want to use a CPU and vice versa. Each piece of hardware has the thing that they're best at, and you should use them for. And if you want to accelerate something, you usually think about a GPU. But as per the previous example, GPUs just weren't built for machine learning. It's an accidental thing where they've been okay at it. They're just not great at it. And so if you have a particularly hard machine learning problem, oftentimes our chip, which is designed specifically for that, will give you much better performance and will be easier to program because you get so much raw performance that you don't have to optimize it as much. And so we accelerate GPUs in the same way that GPUs accelerate CPUs. And so most of the customers that we have are buying GPUs. They're going to continue using GPUs. They have a lot of software that runs on the GPUs. But if you can add a couple of Groq chips to your deployment, oftentimes that'll save you from having to buy a whole bunch of more GPUs. And it'll also help you get more good use out of those GPUs. It's like the Argonne example, where just 16 of our chips displaced the 2200 A100 cluster that frees up those GPUs to work on things that they're actually good at.
So let's talk more about your Argonne National Labs collaboration. I'm very interested about that drug discovery you mentioned earlier, but what else are you doing with Argonne?
Yeah, so we're doing a lot. I mean, they're amazing partners and they're very sophisticated. They've found some interesting use cases that we didn't even imagine for our chip. I guess another good example would be, since this one's just so cool, they've actually been using it for the control loop of a fusion reactor. So we never imagined that when we built this chip, but it turns out that our chip is so fast and you have to do the calculations so quickly. You can't even take a millisecond. It has to be faster than a millisecond, right? So many times faster than a blink in order to be able to keep the magnetic field stable. And so they tried this with GPUs and all sorts of other exotic hardware, and they were never able to get under 3 milliseconds. And so it wasn't really working. And we were actually able to get it down to a fraction of a millisecond. And even in that fraction of a millisecond, it still ran 600 times faster than the GPU. In other words, it gave 600 times as many results. And if you think about it, when you're running a fusion reactor, you're also spending energy on the computation to confine the magnetic field. And if you have to run 600 GPUs versus one of our chips, that's an enormous amount of power. So not only was it fast enough, not only did it give the throughput, but it also saved a ton of energy for this problem. But it's just a really cool application that they were able to get working on our hardware, and it was pretty cool.
That is pretty cool. All right, so let's talk about how your solutions are deployed. Are they cloud, co-cloud, on-prem?
Ah, yes. This is almost a philosophical thing at this point. So, yeah, so I think what's going on in the industry is every company, when they hire a new head of IT, the first thing they do is they convert everything over to run in cloud. And then 3, 4, 5 years later, when they get a new head of IT, they move it on-prem. And then 3, 4, 5 years later, when they get a new head of IT, they move it back into cloud. It just keeps going back and forth, back and forth. And part of the reason is there's some problems with each solution, right? If it's on-prem, you have to manage it. You don't have the variability of capacity. You can't change it. If it's in cloud, they charge a lot. So first of all, we're not going to tell our customers how to deploy things. If they want it on-prem, we'll sell them a system and they can run it on-prem. If the customer wants to use it in cloud, we have a cloud service. And you mentioned co-cloud, so sort of like a co-processor. What we do there is if you have software running in one of the major clouds today, you can actually just call out to our cloud service. And because machine learning is so computationally intensive, there are some applications out there where you send 1.4 kilobytes of data. That's less than those old little floppy drives used to hold. And then someone will run a petaflop of compute on that. So a tiny amount of data, but an enormous amount of compute. And so if you've got one of those problems, then you can just call out to us and it's not that expensive. And we're much faster and much cheaper on the compute. But also some customers want to deploy something on hardware and then use our cloud service to handle the variable amount of the variable portion of their workload. And we'll support either. We really don't care, whatever helps the customer.
That makes sense. Now, I heard that Star Trek matters to you as a leader, so please tell me about that.
Okay, all right. So Groq has 3 values that we live by. So the first one of these values is defying gravity. It doesn't take much explanation to get a sense of how that's related to Star Trek, but there's also the element of Scotty. It's like giving it all I can, Captain, right? Like the miracle worker. There's a big difference between doing what you know how to do and then signing up for what you need to do and figuring out how. And so at Groq, we do a lot of impossible things, and we do that by starting off with what we want to do and then figuring out how. The next one is talent density. At Groq, it's not just that we hire well, it's we try and hire well in every position. And if you ever watched Star Trek Next Generation, you'd probably want to hire anyone on that TV show onto your team, especially that leadership team. They're all amazing, they all have special skills. I mean, Worf as a security guard doesn't get any better. Probably anyone except for Lieutenant Broccoli. Barclay. You'd want to hire, right? So very talent dense. So lastly, intentional leadership. So at Groq, we don't tell people what to do. We hire really great people. So instead, everyone is expected to say what they intend to do to the stakeholders who matter. And if it's the wrong thing, we'll say something. But if we don't say anything, you're free to move forward. And if you notice in Star Trek, Picard doesn't really give that many commands, right? Each of his people are really their own leader. And you see that in the show. But there's one last thing, which is every single episode of Star Trek Next Generation is basically a mini leadership or management parable. Every single one of them starts off with a management problem, a people leadership problem, and by the end gets neatly resolved. And you see like Picard in some episodes get angry at Data, and he's like, "Shut up, Data," and sort of like walking off to his office, kind of pissed off. Like, it's kind of gritty and real in a way that you don't realize. And so I recommend going back and watching it and looking for that, and you'll be surprised just how much it's a TV show all about leadership.
That is absolutely amazing, Jonathan. I've never thought about that in that context, and I'm definitely going to watch it now with that in mind. Wow, interesting. Well, on that note, I think that's all I have time for today. Thank you so much for joining me.
Thank you, and thanks for having me.
Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have that YouTube channel I mentioned earlier, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me, and those newly released fish fry playlists as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of September 16th, 2022, I'm Amelia Dalton, and you've been fried.